Guys, welcome to math class. In today's episode, we are going to be talking about binomial expansion using binomial theorem. Binomial expansion using binomial theorem. In our last episode, we talked about binomial expansion using Pascal's triangle. I gave you some practice questions. Let's check the answers to those questions. Here are the questions given to you in the last episode, Pascal's triangle. Pascal's triangle. Okay? And let's see the answer to those questions. Here are the answers to the question given Pascal triangle. You can pause the video at any time to check your answer carefully. Thank you for making attempts. Alright, that will be all for that. So let's continue with today's topic. At the end of today's class, you should be able to apply binomial theorem to expand binomial expression of positive power. When your n is positive, you should be able to use binomial theorem. Yes, instead of Pascal triangle, you should be able to use binomial theorem to solve any binomial expansion with positive power. Before we kickstart the class, here are starter activities for you to practice. Just pause the video and give these 3 questions a shot. When you are ready to see the answer, please play the video. Alright, let's reveal the answer now. Okay, here are the answers to these 3 questions. Here are the answers to these 3 questions. If you have correct answers to all the 3 questions, well done. If you find it difficult to navigate through those 3 questions, this episode is for you. Come, let's discuss. In our last episode, we talked about Pascal triangles, and I told you when you have a coefficient, you can easily expand any degrees in as much as it is positive. Now, for this, the prerequisite to this course is our combinations. We know selection of an object. If I write n combination R, it means out of n items, R is selected. Out of n items, R is selected, and we can simplify it as n factorial over n minus R factorial, That's the expansion, and this can also be written as nr. Simply, you can simply put it as nr, and you can simplify this using your calculator. Alright, if you are asked to expand any binomial expression of a plus b raised to power n, let's check the general expansion for the binomial theorem. If you are given a plus b raised to power n, like what we did in Pascal triangle, I told you that you pick out the coefficient, write out the coefficient, and as the power of a is decreasing, power of b is increasing. To do this, you put your n combination 0, a n b raised to power 0 plus n combination 1, a n minus 1 b raised to power 1 plus n combination 2, a n minus 2 b raised to power 2 plus n combination 3, a n minus 3 b raised to power 3, and so on and so on and so on. You can continue the expansion. Mind you, this can be written as n0, a n plus n1, it means n combination 1, an minus 1 b plus n2, okay, an minus 2 b raised to power 2, and so on like that. So wherever you see n0, it means n combination 0. And from this key that I have here, if you are to expand open bracket a plus b close bracket raised to power n combination 0 an plus n1 an minus 1 b raised to power 1 plus n combination 2 a raised to power n minus 2 b raised to power 2, and so on until you get to n combination n b raised to power n. So that is the expansion for the binomial. Now let's take some questions. At the end of this class, you should be able to solve, yes, you should be able to solve question on exercise 6b. Okay, all right, I'll pick some to do, but let's just see. If I have I've told you that when you have n r is the same thing as n combination r, please take notes. So if I have 7 2 is the same thing as 7 combination 2, that is, out of 7 items select 2, and you can type this straight up on your calculator. I've told you this one gives me an expansion like this one is n factorial over n minus r factorial, So if I want to do this, it will be 7 factorial all over 7 minus 2 factorial, which will be 7 factorial over 5 factorial times 2 factorial. 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial is 5 times 4 times 3 times 2 times 1. Then the other 2 factorial that we have will be 2 times 1. So this one can cancel out this, and 2 here 1, 2 here 3. So 3 times this give me 21. So we have 21, meaning that 7 combination 2 or 7 2 is still the same thing as 21. You can evaluate straight up your calculator. So please, that is how to do. Take these examples. I will just do one. Which one should I do? Oh, I can hear you screaming question C. To do question C, to have 1 plus x, and we have 1 minus x over 2 all raised to power 8. The question says we should find in ascending order of x the first 3 terms. So I need to first deal with this guy, then I will now multiply the expansion like what we did in Pascal triangle. My n is 8, my a is 1, and my b is minus x over 2. So the expansion for 1 minus x over 2 all raised to power 8. So let's start. I have my n, that is 8 combination 0, and I have my first term 1 raised to power 8 plus 8 combination 1, first term raised to power 7, and the second term, which is my b, raised to power 1. Okay, so I move on to do 8 combination 2, and I have first term raised to power 6 and minus x over 2 raised to power 2. So the question asked me to do the first 3 terms. This is 1, 2, 3. Let me just do the first 3. So the expansion of this continues, but I don't need it because the question has asked me to do the first 3 terms. 8 combination 0, you can do it on your calculator, and that will give me 1 plus 8 combination 1. 8 combination 1 will give you 4. How do we arrive that? You can press it straight up on your calculator. It's the same thing as 8 factorial, 8 minus 1 factorial, and 1 factorial. So I'm going to have 8. So everything here will give me 8. So I have 8 bracket minus x over 2. So I'll come to this side plus I have 8 combination 2, which is 8 factorial over 8 minus 2 factorial over 2 factorial. That will give me 8 times 7 times 6 factorial, and 8 minus 2 give me 6 factorial times 2 factorial. So this 6 factorial will take care of 6 factorial. 2 here 1, 2 here 4. So 4 times 7. 4 times 7 will give me 28. And I will have x over 4 because I have minus x squared, that is minus x times minus x squared over 4, plus the expansion can continue. 4 here 1, 4 here 7. I have 2 here 1, 2 here 4. So the expansion of the second binomial expression there is minus 1 minus 4x plus 7x squared plus dot dot. So that is the answer to this second one. So I'll now multiply it by my red parts. So let me just pick black marker, okay, black ink, and do it here. So I have 1 plus x, and the expansion that I've done, 1 minus 4x plus 7x squared plus dot dot dot. Dot 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 still show that the expansion continues. So let me use 1 to multiply everything. I will get 1 minus 4x plus 7x squared plus, I'm using x to multiply now, x minus 4x squared minus 7x cubed. So I can rearrange and collect like terms. I have 1, this 4 and this will give me minus 3x. 7x squared minus this will give me plus 3x squared, and I have minus 7x cubed. Okay, the question asked me to do the first 3 terms. So finally, the first 3 terms that I'm looking for will be 1 minus 3x plus 3x squared. So that is the answer for that. In simple term, anytime you want to apply binomial theorem, you use n combination r. As your A is decreasing, your B is increasing. You can go over the video again, and in the next episode, we'll talk about this.